Okay, 6.1, the polynomial angle sum theorem. Polynomial, not a polynomial. I'm doing polynomials all day. Polygon, okay? A polygon is a shape. It is a closed shape that has sides. See this? Shoot. That is a convex polygon. This is a concave polygon. What is the difference?
The sides are not all the same.
Well, they aren't here either. This is convex. This is concave. What does concave mean?
It's not an actual shape.
Yeah, but what happens if something concaves in? It collapses, yes? Did this collapse into the shape?
Yes.
Yes. This is a concave and this is a convex. Just so you know. Okay? There are blank triangles in every n-sided polygon. Okay, so here's an n-sided polygon. How many sides do I have? One. I hate when I touch it. So 1, 2, 3, 4, 5, 6. Yes? So from a vertex, I drew 1, 2, 3. So how many triangles did I get? 4. So I had 6 sides and I have 4 triangles. And I'm just going to use this picture over here just so we can draw on it. This one has 7 sides. And I'm going to draw 1, 2, 3, 4 lines. So I have how many triangles? 5. So I had 7 sides and 5 triangles. Well, what if I had 10 sides? How many triangles do you think I'd have? I had 6 sides, 4 triangles. 7 sides, 5 triangles. 8. If I had 12 sides, how many triangles? 10. How are you guys doing that?
Subtract 2.
Taking the number of sides and subtracting 2, yes? And it says n-sided, so n is the number of sides, right? So we need to put n minus what? 2? Make sense? Okay, so everything we do today, I'm going to kind of build. I'm just going to talk about it, why it is what it is. Because there's some formulas today, but why is the formula what it is, okay? So any polygon, if I told you there was 128 sides on a polygon, which is pretty much a circle, right? Depending on how big the sides are. How many triangles would there be? 128 sides, so how many triangles? 126 triangles. Because we go from one vertex and it's 2 less, right? Okay, so now I want the sum, and you want a sum of the interior angles. So sum means add them all up, yes? Mm-hmm. Interior means inside? Yep. Okay. Well, I'm going to look back at my triangles here. If I have this triangle over here, I have this angle plus this angle plus this angle. What does it add up to be?
180.
180. Okay. And then this angle plus this angle plus this angle is what? 180. And then I have this angle plus this angle plus this angle is what? 180. And then I have this angle plus this angle plus this angle equals what? 180. Well, I have 4 triangles that all add up to 180. So what would all the angles add up to be? 4 times what? 180. So that'd be 0, 2, carry 3. It'd be what? 720. Well, why was it 720? Because I had how many triangles? 4 triangles, and all the angles in a triangle add up to what? 180. So the formula is, guys, 180 times the number of what? Number of triangles. And what was the number of triangles? No, what was the number of triangles? N minus 2, wasn't it? We're talking about for any polygon, right? So we just built a formula. I didn't just tell it to you, did I? Do you know where it comes from now? Yeah. All formulas have where it came from, why it is what it is. And that's what I think geometry should be. Because honest to God, you're not going to remember the number of sides. But you can say, well, I know there's this many triangles, and I know there's 180 degrees in each triangle, right? And you can multiply it. So your example says there's how many sides? 1, 2, 3, 4, 5, 6, 7. So if there's 7 sides, how many triangles does there have to be?
5.
5. And if there's 5 triangles times 180, so 0, 0, carry a 4 is how many degrees?
100.
900.
900.
Make sense? Okay, questions? So, example, how many triangles are formed by drawing the diagonals of the vertex of a convex octagon? Octagons, how many sides? 8. So I could draw them because I have it right here, yes. Or I could use my rule, which says n minus what? 2. So 8 minus 2 is what? 6. Do I have 6 triangles? 1, 2, 3, 4, 5, 6. Then it says, what is this, the interior angle sum of a convex octagon? And this is important, guys. These are all convex rules, not concave. If it's concave, is it going to change the rule a little bit? Yeah. Okay. Well, how many triangles were there? 6. How many, what's the angle is that up to be? 180. So 180 times what? 6. So 0, 8, 4, 1080 degrees. You have to remember your degrees. So again, our formula is 180 times n minus 2. N minus 2 tells me what?
Number of sides.
Not number of sides. N is the number of sides. What does n minus 2 tell me? The number of what? Mm-hmm.
Wait, so did you just
The number of
add
triangles.
the 6 and 4?
N would equal the
Yeah.
number of...
Because I was multiplying.
wouldn't
1
N
times
equal the
6
number
is
of
6
sides?
times 4.
Uh-huh.
N is the number of sides. N minus 2 is the number of triangles. Ryan, you get that?
Mm-hmm.
Okay. Any other questions? Pretty basic?
Yeah.
Okay. It's going to get harder. Okay. So now we need the measure of the interior angles of a regular. Do you guys remember what regular meant?
Nope.
All the sides were the same. Okay? Regular means all the sides are the same length. So if all the sides are the same length, what do we know about all the angles? They're all the same. So if we know how to find the sum, I'm going to go back here. We found the sum of all these angles, yes? And it was 1080. And I told you there were 8 equal angles. How would you figure out what one of them equaled? This is the total sum right here.
You did 180 man.
No, I've got,
Divide by
you divide by what? How many angles do I have?
8.
8. So I divide by 8. Wouldn't I? Because they're all equal. So you find the total number of degrees in there and divide it by the number of sides, right? So that's our formula. I would use this. You probably can't see that green very well, can you? Right, you have to tell me. Use your blank as a division bar. Okay? So we said the total number of angle, right? So that was 180 times n minus 2, wasn't it? Number of triangles times 180?
Yes.
Divided by n, which is the number of sides, but is it also the number of vertices? Yes. So that is the formula for this. And again, did we just figure that out without me saying there's the formula? Yeah. So if I have a pentagon, I have 180 times the number of triangles. So 5 minus 2 is 3. So 180 times 3 is 0, 4, carry a 2 is 540. Yes? Divided by the number of vertices, which is
5.
5. 5 goes into 5 how many times? 1. Does 5 go into 4? Nope, so 0. 5 into 40? 8. So each one of those angles is how much? 108 degrees. We broke that down pretty basic, didn't we? I want you to think about what you guys are doing, not just here's the formula, plug stuff in. Because are you going to remember those formulas probably in 2 months? No. But could you break it down into triangles? Yes. Okay, am I ready to move on? So, what is the interior angle sum of a 17 gone? And I touched it without turning on my pen. So I have 17 sides, yes? I am not drawing a 17-sided polygon. Sorry, not going to happen. Okay, so what is the sum? How do I find that? The interior angle sums. The number of triangles times what? 180. So how many triangles are there? 15. How'd you get 15? Okay, so here's a trick for multiplying by like 15, 25, things like that. 15 is 10 plus 5, yes? What is 180 times 10? Real quick. 1,800, yes? Okay. Now multiply times 5. So 5 times 0 is 0. 5 times 8 is 40. Carry your 4. 5 times 1 is 5. Plus 4 is 900. And we get what?
900. Oh, yeah.
2,700. Okay? Anytime I have to do like 15, 25, 35, easy things like that, I break it up into two numbers that are easy to multiply by. You don't have to. Okay? Real quick while I'm thinking, if you guys haven't got a calculator, we're going to be using them almost daily, so you need to work on getting one, okay? If you're going to have to purchase one, I would suggest you get a TI-34. It's a 2-line calculator. Would you guys like me to post on our page what the best one would be? You don't have to go buy one if you already have one. You understand me?
Yeah.
But I will post on there the best one if you are going to buy one. They're like $10, $12 at Walmart. Okay? I'm not sure if the dollar store has them. They may have a Casio, but I don't know how to run a Casio. I've got like 3 Casios up here that people have just left behind because they don't know how to run them either. Cool. So, don't waste your money. I think they're like $2 or $3 cheaper, but if they're cheaper and you don't know how to use them, they're not any better, right? So, work on getting a calculator. If you already have one, use what you have. We'll make it work, okay? But if you don't have one, I want you to have a 2-line one, because the 1 line, you just see one thing you're doing. On a 2-line one, it will tell you the answer, but it also shows you like the equation that you typed in, so you know what you typed in. And that could be useful, right? So I will post that on there. That's just my brain, because we're getting into, not today, but we're getting into needing them. Okay, so now we have each angle of a regular n-gon measures 172.8. So that told me what the angle is. It wants to know how many sides I have, doesn't it? Mm-hmm. So I have to use that formula that we just made backwards. Okay? So the formula we just had here, right? The 180 times the number of triangles divided by the number of vertices, right? We have to use that backwards. You guys ready? I'm going to tell you, do not be writing huge. You probably will run out of room today, because I had to make it smaller to fit on one page, to fit on those 2 pages, because we like that, right? Just on 2 pages. Okay, so that equals 172.8 equals that formula, 180 times the number of triangles divided by the number of vertices, or number of sides, either one you want to say. Okay, now we got to solve that. We're done with the geometry. We have algebra. So, anytime we have something in a denominator and we're trying to solve an algebraic equation, we need it out of the denominator, don't we? So we need to multiply both sides by the denominator. So on the right-hand side, those ends reduce out, don't they? Yep. And on the left-hand side, we just have 172.8 n. Okay. On the right, what does this 180 in front of the parentheses tell me I have to do?
Time, but
I have to distribute it. I have to multiply, don't I? Okay, so 180 times n is 180 n. And 180 times negative 2 is negative, right? And 2 times 180 is 360. And now I just have an algebra problem. So how am I going to solve that? Subtract 180. Now I'm going to show you guys a little trick that I do to make the math easier. I'm going to subtract 180, but 180 is bigger than 172, isn't it? So instead of writing it under it, I write it,
You just make it negative.
I make it negative because subtraction is making negative, right? I put it above it. Is it easier for our brains to do that subtraction? Yeah. Great minds, Henry, great minds. Okay, so now I got to make this a 10, right? And this a 9, and this a 7. Okay, so 10 minus 8 is 2. And then 7. And then it's going to be a negative, right? And on the other side, I subtracted the 180, so I get negative 360. Now I have to do what? Not add. Divide, because that's multiplication, yes? I have to divide by negative 7.2. Now, I look at that and my brain wants to exit the building. Anybody else? Yes? Okay, so first of all, a negative divided by a negative is a what? Positive. So plus plus. When I have a decimal in the denominator, I have to multiply by a power of 10 to move it, correct? If I move it in the denominator, I have to move it in the numerator. And that makes it 3,600 over 72. Okay? Now, I don't want to divide 3,600 by 72. My brain doesn't want to do it. I'm lazy, and I know all of you are too. All right? But is there a number that can go in both 36 and 72? What?
36.
36. Does 36 go into 72? Yes. When I was doing my notes, I saw 12. I can do 12, right? And I just do it again. I wouldn't start with 2 because that's kind of small. You'd have to keep going. Okay, so how many times does 36 go into 36? 1. So that makes it 100, doesn't it? How many times does 36 go into 72? Twice. Well, do you know 100 divided by 2? 50. So how many sides were in this? 50 sides. So we did that division that looked absolutely horrible. And was it horrible?
Yes.
No. I'm trying to show you ways that you can do that math and not overexert yourself. Make sense what I'm trying to do?
Yes.
Okay, questions? Some of these problems are going to be a little bit involved. Okay, now, I want us to think about this. The sum of the exterior angles. Look at my picture. That's all of these. Oh my gosh, every time. That's all these angles, yes? Now, this is really easy. This will be the easiest thing you do all day. What happens if I draw a circle that each of these vertices touch? They all equal 360. It's called an inscribed polygon. Why is it inscribed? Because it's inside what? A circle. Okay? It's inscribed. All of these angles add up to a circle, which is what? 360 degrees. But these are only what? Angles. Exterior angles. I'm going to push that because everybody's like, ooh, everything's 360. No, we already showed you the inside isn't always 360, is it? But what is the outside always? 360. And that's also why a circle isn't a polygon. Because a polygon is a multi-sided object. Is a circle multi-sided?
Actually, it's one side.
It only has one. Which is it multi, is it? Okay, so here's your hardest question of the day. What is the sum of the exterior angles of a convex 17-agon?
360.
360.
Good job, dude.
Don't forget your degrees.
So every sum will equal 360.
Exterior, yes.
360.
Okay.
No.
Now we're not... Now we're going to go into some work. You ready? Okay. So we have this shape down here as a pentagon, yes? Okay. It is obviously not a regular pentagon, is it? What's regular mean? All the sides and angles are equal, right? Okay. But it tells me angle 1 and angle 2 are congruent, yes? And angle 1 equals 3x. So I'm going to write at angle 1, I'm going to write what? 3x. Where else am I going to write 3x? At 3. Guys, make your 3 a 3x. Okay. Then it tells me angle 2 is what?
2x.
2x. Make your 2 a what?
2x.
2x. Oh, what's 4 and 5?
90 degrees.
How do we know they're 90 degrees?
There's a square.
Because there's a square on the inside, and if on the inside it's 90 degrees, on the outside it has to be 90 degrees because the straight angle, correct? Okay, so 5 is 90. And it says, what is the measure of each exterior angle? Well, we know all the angles have to add up to what?
360.
360. So I know they have to add up all to 360. So couldn't we do this equation and figure out what x is and plug it back in? Okay. So I have 90 plus 90 equals what?
180.
180. Plus, how many x's do I have? No. Do not tell me 3.
2.
I have 3 x's and 3 x's and 2 x's. How many x's do I have? 8. Correct?
Yes.
Okay, I just combined like terms, didn't I? Could I have written them all out? Could I have said 90 plus 90 plus 3x plus 3x plus 2x if I wanted to?
Waste of time.
Waste of time. We know how to combine like terms, don't we? Okay, now what do I do?
Subtract 180.
Subtract 180,
And you get 180.
and I get 180 equals
8x.
8x.
Divide.
Divide. Okay, do you want to divide by 8 or do you want to reduce it and then divide?
Divide by
Reduce. Okay, you divide by 8, Ryan, and we'll reduce and divide and see what we get. What goes in both 18 and 8?
16.
2?
Yep.
Okay, how about 4?
No.
Yeah.
Okay, if 4, does 4 go into 80? Does 4 go into 80? Yes. So it goes into the whole thing. That's the trick for 4s. Okay, so 4 goes into 18 how many times? 4 goes into 18 how many times?
4.
4. With 2 left over. 4 goes into 20 how many times? 5. 4 goes into 8 how many times? 2. Okay. 2 goes into 4 how many times?
Twice.
Twice. 2 goes into 5 how many times?
Twice.
With 1 left over?
Yeah.
So 2 goes into 10 how many times?
5.
5. So x equals what?
22.5.
22.5. So if I know x equals 22.5, all I have to do is throw it back in, right? Yes? Ryan, did you get 22.5?
Yeah.
Okay. So I know angle 5 is congruent to angle 4, which is what? What's 4 and 5 equal?
90.
90. That was given to me, wasn't it? Okay. And then I know that angle 1 is congruent to angle 3, which is 3 times 22.5. Okay, 3 times 5 is 15. Carry a 1. 3 times 2 is 6 plus 1 is 7. And then 6. So 1 and 3 is 67.5. Okay. And angle 2 is 2 times 22.5. Well, guys, we just had it over here. We divided it. So it's what?
Do what? 45.
45. So once we find x, do we have to plug it back in? Yeah. And it took us a minute to find x, but was it hard?
Yes.
No.
Difficult.
Questions about what we did? Okay, when you guys are finished, let me know because I'm going to erase because you have more room than I do. I should have put it on 2 slides and I didn't.
Get next one by yourself.
Is everyone ready for me to erase? Okay. Okay, so now what's the next one? Tell me.
So column 1, 3, 4, 5.
So it says angle 1, 3, 4, and 6 are all congruent. That's nice, right? We find one of them and we have 4. Ooh, good, because we have a hexagon and that's 6 angles, right? We know that angle 2 is congruent to angle 5, so we know that. But we also know that the measure of 3 is angle 2 plus 30, don't we? Don't we? So could we call like angle 2 and 5 x? Could we put an x on those? Could we do that?
Yeah.
Okay. So 2, I'm going to put an x. And 5, I'm going to put a what? X. Because they're congruent. Yes? And if we know that angle 3 is angle 2 plus 30, what did we just say angle 2 was?
X.
X. So wouldn't that be x plus 30? So we could write that where? On which angles?
2 and 5.
3 and 4.
Well, 2 and 5 are x. We can write x plus 30 on 1, 3, 4, and 6, can't we? So x plus 30, x plus 30, x plus 30, and x plus 30. Kind of repetitive, but it's nice. We only have 2 different measures, don't we? Okay, what do we know that all of those equal? 360. Who said 180?
That was Cooper.
Yep.
So we need to solve the equation. We got to combine like terms, right? How many x's do we have? 1, 2, 3, 4, 5, 6. So 6 x's. And we have 30 plus 30 plus 30 plus 30. So 4 times 30 is 120. Now we just solve it, right? Subtract 120.
240.
Oh, this is easy division.
That's hard.
6 goes into 24 how many times?
4.
4. So it's 40.
Yeah.
So now what is 5 and 2 and 5?
40.
40. Because 2 and 5 is x, right?
And
So
the rest-
angle 2 is congruent to angle 5, which is what? 40 degrees?
Yeah.
So
okay.
Would it be 40 plus 30?
Yep. And then angle 1 is congruent. We got to write all this, though. To angle 3, which is congruent to what? Angle 4,
6.
which is congruent to angle 6, which is x plus 30. So 40 plus 30 is 70. How could we check our work if we're right? Make sure they add up to what?
360.
360. So I had 2 angles at 40. So what's 2 times 40?
80.
80. Plus, and I'd, how many angles at 70? 4. So 4 times 70 is
280.
280, which is
360.
360. So we're going to have to come up with some equations sometimes. Yep. And I give you 2 days. We're practicing this stuff for 2 days. Okay. One more example, right? So we got. Are we ready to go? Evidently, I didn't need to erase. I could have fit it all in one. Okay, now we're not on the outside. We're on the what? Inside. So we can't just say it equals 360. We got to use our equation from before. How did we find the sum of all the inside ones?
New triangles.
How many triangles times what? 180. So how many sides do I have?
1, 2, 5.
5. Okay. So I have 180 times 5 minus 2, which is 3. So 180 times 3. So 3 times 0 is 0. 3 times 8 is 24. Carry a 2. 3 times 1 is 3. Plus 2 is 5. Okay, so we know all those angles up to how many, add up to how many degrees? 540. So now we just make an equation like we did on the last one, right? Guys, can we label these A, B, C, D, E? I hate that they didn't label them. Because it gets messy, doesn't it? Okay. None of these are the same, though, are they? Shoot.
Well, D is
Okay, 540. And what did you say D was?
90.
How do you know D is 90?
So that's that bar.
Right, so we already know that angle D equals 90. Got one of them out of the way, right? Okay, so 540 equals, well, I got 3 x's and 7 x's is how many? 10. And I have 6 and 6, which is how many?
12.
And 10 and 12 is? 22. Or whatever order you would like to add things up. Guys, I add things to 10. Do you, anybody else? Like you find 10s? Okay. So now I have 4 minus 3. 1.
13.
Plus 12 is 13. Minus 3 is 10. Plus what? 90?
100.
Which is 100. Where'd the 90 come from?
Right angle.
The right angle. And so now what?
Subtract 100.
Oh, well, this is going to be easy division too, isn't it? Well, 22 goes into 44 how many times? Twice. And then throw a 0 down there? So what do I need to do with that?
Plug it in.
Plug it in. So angle A is going to be 2 times
64.
3. So 60 plus 4 is 64. Angle B is going to be 20 times 7, which is 140. Minus 3, which is
137.
137. Angle C is going to be 6 times 20, which is 120 plus 12,
Is 132.
132. D was 90, right? And E is 120 minus 3 is
117.
117. Now, how do I check my work here?
Don't.
Add them all up, and they have to equal what? 540? So we have 4 plus 7 is 11. Plus 3 is 13, right? Plus 7 is 20. So I have a 0, carry a 2. I have 2 plus 6 is 8. Plus 3 is 11. Plus 3 is 14. Plus 9 is 23. Plus 1 is 4, 24. Carry another 2. So 2 plus 1 is 3. Plus 1 is 4. Plus 1 is 5. So do they all equal 540?
Yes.
Yes. Cayenne, hood, please. Okay, so you might want to draw a rough picture, or you might not. Okay? I like to draw a picture, really rough picture, so I can label it. Could I have done this differently? Could I have written 3x plus 4 plus 7x minus 3 plus 6x plus 12 plus 90 plus 6x minus 3 and then combine like terms?
Waste of space.
Could I have done that? Though? Yes. Okay. Do what work you need to do. Got me?